Hello, welcome to my channel. Today we will see one more problem on plane scales. So the problem is like this. A real length of 1 decameter is represented by a line of 5 centimeters in a drawing. Find RF and construct a plane scale to measure up to 2.5 decameters. Mark a distance of 19 meters on it. So in the previous class, we have drawn one plane scale problem. In that, RF was directly given. But whereas in this problem, RF is not given, we have to find out the value of RF, then length of scale, and we need to construct a plane scale. So here what is saying is, so when we see the formula for RF, representative fraction, RF. So we know the formula that RF in simple words, that is assumed length by actual length, or we can say assumed drawing by actual drawing, or assumed size by actual size. So here if you see the problem, so he's saying that 1 decameter is represented by a line of 5 centimeters. So if you take a sheet, and if you want to see, if we want to represent the decameter with 5 centimeter line, we can say like, so if we represent this, we can represent this 1 decameter by a line of 5 centimeters in this way. So for example, see, if you take on a sheet, say this is some 5 centimeters and its original distance is 1 decameter. So on a sheet what we are doing is, we are representing 1 decameter by using a 5 centimeter line. So in this case, 1 decameter is nothing but the original size or original length. This original length is represented by a 5 centimeter line. This is assumed. We have assumed a 5 centimeter line and we have shown 1 decameter on that. So if you see the problem and the formula, RF will be assumed length by actual length. So RF can be written as, what is assumed length? Assumed length is 5 centimeters and actual length is 1 decameter. So here we have to convert this 1 decameter into centimeters. So this can be written as 5 centimeter by 1 decameter. So what is 1 decameter? If you see the conversions, metric measurement conversions, 1 decameter will be 10 meters. And 1 meter is equals to 10 decimeters. 1 decimeter is equals to 10 centimeters. So this is the conversion of decameters to centimeters. So here we can write 5 centimeters divided by 1 decameter into 10 meters into 10 decimeters into 10 centimeters. So this will be 5 centimeters divided by 1000 centimeters. So we'll get 1 by 200. So this is the RF. Therefore RF is equals to 1:200. Right? Now next we need to calculate length of scale. Length of scale, that is LS. LS is equal to, already you know the formula, that is RF into maximum distance or maximum length. Okay, so RF already got 1 by 200 into, what is the maximum distance? Maximum distance is, here it is 2.5 decameters. So 2.5 decameters. So we can write this as 1 by 200 into 2.5 decameters. So we can convert this 1 by 200 into 2.5 decameters. Already we have seen 1 decameter is equal to 10 meters into 10 decimeters into 10 centimeters. So we get length of scale as 12.5 centimeters. 12.5 centimeter. Okay, so we got RF as 1:200 and length of scale as 12.5 centimeters. Now we'll construct a scale. We'll construct a scale of 12.5 centimeters. 12.5 centimeters. Okay, 12.5 centimeters. And height of the scale already I said that it is 10 mm. 10 mm. Right, so this is LS is equals to 12.5 centimeters. So now you divide this 12.5 centimeters into maximum distance length. So the maximum distance in the problem is given as 2.5 decameters, right? And the marking distance is 19 meters. Marking distance is asking us to mark a distance of 19 meters, and the maximum distance is mentioned as 2.5 decameters. So you convert these 2.5 decameters into meters. That is 2.5 decameters into 10 meters. So that will be 25 meters. 25 meters. So now this is the maximum distance in meters. 25 is the maximum distance in meters. So now you divide this 12.5 centimeter scale into 5 equal parts. 5 equal parts. Okay. So 5 into 5, 25. So 5 equal parts. So take a less than 45 degrees line. Less than 45 degrees line. Okay, and with some convenient radius, you cut this inclined line into 5 parts with same radius. Say 1, 2, 3, 4, and 5. Say this is 1 dash, 2 dash, 3 dash, 4 dash, and 5 dash. Now you join 5 dash and point B. Say for example, see this A and B, join 5 dash and B. Fix your drafter and draw all parallel lines, equispaced lines from all the points. That is 4 dash. Move to the third point, that is 3 dash. Next 2 dash. And finally 1 dash. So now mention it as 0, 5, 10, 15 and 20. Now you draw all vertical lines from these points. 0, 5, 10 and 15. So we have to draw all vertical lines. So 5, 10, 15, 20 and 25. So this is the main scale, that is meter scale. So we have to write here meters. meter, right? So actually here marking distance is 19 meters. So both are in meters only. Both are in meters only. So there is no decimal point in between. So we cannot go for next conversion. So marking distance is 19 meters only. So already we have 5, 10, 15, 20 and 25 meters. So now we can divide this 5 meters into 5 parts. 5 meters into 5 parts. Why? Because marking distance is 19 meters. Okay. So divide this into 5 equal parts. 5. So same procedure, that is less than 45 degrees. So with some convenient radius, what we are doing is we are cutting this inclined line into 5 parts with same radius. Right? So now join, so this is 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. Join 5 dash and 0. Fix your drafter and move on to the next point and draw another line. Next point 3 dash, next point 2 dash, next point 1 dash. Now you draw all these lines vertically downwards. Right? So we have divided this into 5 meters into 5 equal parts. Say this is 0, 1, 2, 3, 4 and 5 meters. Okay. So we have to mark 19 meters. 19 meters. So here main scale is 50 meters only and subscale also in meters. Subscale also is in meters. So right here this is also in meters. Meter. Divided this 5 meters into 5 equal parts, that is 1 meter, 2, 3, 4 and 5 meters. So here subscale is in 1, 2, 3, 4, 5 meters. We wrote here meter. So both main scale and subscale both are in meters. So now we have to mark 19 meters. So main scale it is 15 and here in subscale it is also in meters. Okay, so that is 1, 2, 3, 4, 5. So from 4 you draw a line, right? So this is your 19 meter. So this is the way to draw the plane scale when RF is not given. We have to find. So both the scales are in meters. So main scale is in 5 meters, 10 meters, 20, 15, 20 and 25 meters. And subscale is also in meters, that is 1, 2, 3, 4 and 5 meters. Okay. So now we have to mark, that is 19 meters, that is 15 meters and 4 meters. 15 plus 4, 19. So total is 19 meters.